Section 4.2 is on page 260. It talks about integer representations and algorithms. Now, the representation is essential, especially for programming, something that you need to do. The definitions and theorems are a bit confusing, but the examples I'm going to expand to make sure that you grasp this concept. It says that b be an integer greater than 1. If n is a positive integer, it can be expressed uniquely in the form of n equal a sub k some number times b to the k, where b is the integer greater than 1, then another number times b to the k minus 1, all the way a sub 1 some number times b to the power of 1, and the last piece would be times b to the 0, which is 1, where k is a non-negative integer. A sub 0 through a sub k are non-negative integers less than b, always less than b, and I'll show you why, and the leading a sub k cannot be 0. Here they're talking, the reason I copied this down, you need to really grasp the 8s, they're right here, the 2s, binary, the 8 octal, and the 16 hexadecimals. They talk about a base of 10. Those are reserved for integers. We really don't use that much in programming. Binary expansion, choosing 2 as the base gives binary expansions of integers. Choosing the base to be 8 makes that octal, and choosing the base to be 16, that would be hexadecimal. And these are the three we're going to focus on. Just to make sure we're clear on this, the hexadecimals run to 16, but there are no 16 numbers. So things don't repeat. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. This is 11 numbers, 12, 13, 14, 15, and 16. Again, it has to be less than 16. If it's 16, then the remainder will be 0. You go back to the start. So those are a bit annoying. A, B, C, D, E, F. You have to remember this: 10, 11, 12, 13, 14, and 15. Again, this is going to be a really simple thing to do. I'm going to go through examples and expand on them to run back and forth between all of those. So, on problem number 2, and this is on page 269, I'm going to do beyond what they're asking. So they say convert the decimal expansion of each of these integers to binary. They want it to be 2. I'm going to do binary, octal, and hexadecimal in all of those. So 321, the way to do it, you would take 321 and you would divide that by 2, and that would be 160, and you have a remainder of 1. And then you take 160 divided by 2, that's 80, remainder of 1. And you take 80 divided by 2, that is 40, remainder I meant a 0. Just kidding. And 40 divided by 2 is 20, remainder of 0. And 20 divided by 2 is 10, remainder of 0. 10 divided by 2 is 5, remainder is 0. 5 divided by 2 is 2, remainder of 1. And 1 divided by 2 is 0 plus a remainder of 1. What this means, you copy those down in that, oops, the color didn't register. You copy those down in that order. So you say this is, 321 is, and you start from the bottom, 1, 1, 0, 0, 0, 0, 0, 1. And you write them like this, in pairs of 4. And there's a reason for that. So 321 is 100001 in binary code. If I take that same 321 and I want to write that, instead of binary, I want to write that in octal, I divide it by 8. That is 40 plus 1. Take 40 divided by 8, that's 5 plus 0. Take 5 divided by 8, that's 0 plus a remainder of 5, so that would be, start from the bottom up, 501, with the subscript of 8. telling that, guess what, this is the binary, this is the octal expansion. And if I take 321 and I divide that by 16, again, these are the only ones we're going to focus on. That's 20 plus 1. Take 20 divided by 16, that is 1 plus 4. And take 1 divided by 16, that is 0 plus 1. From the bottom up, 321 will also be 1, 4, 1 in hexadecimal. And I'm going to do that in every problem so we really get used to this, forward and backwards. Given the number, give me the binary expansion. Given the binary expansion, give me the number. Same with the octal, same with the hexa. I'm going to do the same with those. So let's look at the next problem. Now we're going to go the other way around. We want to start from, and I'm doing an example on each of those, you'll see that. If I take this, I'm going to write this. So this is how it works. You always start from the right, and you always start with 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, 2 to the n, friends up. So this is really 2 to the 0 plus 1 times 2 to the 1st plus 1 times 2 squared, 2 cubed, and 2 to the 4th. And if you work those out, that's 16 plus 8 plus 4 plus 2 plus 1. That's 20. That is 31. If I didn't make a mistake, that's what that will be. Now, I'm going to look at C. Well, the same deal will happen. This is 2 to the 0 plus 0 times 2 to the 1 plus 2 squared plus 0 times 2 cubed, 2 to the 4th, 0 times 2 to the 5th, 2 to the 6th, 0 times 2 to the 7 plus 2 to the 8. You plug this in a calculator and that turns out to be, if I'm not mistaken, 337. I'm not sure where I'm using red. I was warned not to use red, so let me stick with a different color. Alright, now if I want to change that to a base of 8, well, again, this first number, so you start with always 8 to the 0, the second number 8 to the 1, 8 squared, 8 cubed, and the list goes on. So this is 4 times 8 to the 0, plus this is 0 times 8 to the 1, that's going to be 0 of course, 6 times 8 squared, and 1 times 8 cubed. And the order always works that way. And if you plug this in a calculator, I believe you're going to get 900. Now, for practice purposes, let's reverse the order to make sure we see it. If you take 900, you want to write it in octal expansion divided by 8. That's going to be 112, and you're going to get a remainder of 4. And if you take 112 divided by 8, that's going to be, oh, crap, I didn't copy that down. Okay, I worked it out. That's 14 plus 0. Instead of remainder, you should say plus 4. There you go. And if you take 14 divided by 8, that's of course a 1 remainder of 6. And 6 divided by 8 is 0, and the remainder is... let me get this straight. Oh, sorry, not 6. 1 divided by 8. I was going to say it's not working. Remainder is 1. Right? So you start from the bottom up. That is 16048, which is what we started with. I know it's a bit messy in the beginning, but you'll get the hang of this. Now on number 6, let me go the other way around. The other way around is really what you need to do as well, and this one I'm gonna show you how to do for all, even though it says write it in octal. I'm gonna use the binary to octal and hexadecimal on each of those. I'm gonna do all 3 on every problem. So the way it works, to go to octal, you need to break them into 3s, and I'll explain why is that in a minute. So you need to break those into 3, space a bit, 3, and there's only 2, not a problem, at a 0. And the reason for that, if I want to go for a base of 8, then I need the numbers to be less than 8. So this 2 to the 0 is 1, 2 squared is 2, 2 to the 1 is 2, 2 squared is 4. If you add those, that's 7. If you add 1 more, then that's going to be more than 8, and that wouldn't work. So that's how it works for the 8. So when you look at this first number, that's 2 to the 0 plus and plus. Well, 4 plus 2 is 6, that's 7. This number, 2 to the 0 times 0, there's none of that, but there are those 2. 4 plus 2 is 6. Here, 2 to the 0 is there, 2 to the 1 is there, but 0 times 2 to the 4th, so you add those 2 and you get a 3. So that is 368 in octal expansion. And if I want to do the same problem, I know they're asking for octal. I'm going to do hexadecimal. For hexadecimal, if I want to write that as a 16, I'm going to write them in 4. So 3, because I can only use 3 of those. But if I write 2 to the 0 is 1, 2 squared is 2 to the 1 is 2, 2 squared is 4, and 2 cubed is 8. This is as far as I can go because that's 10, that's 15, less than 16. Now I need to take this and break it into 4. So I take those 4 for starters. That's normally how they're written, which is good. And 1, 1, 1. And if they're missing anything, you could add a 0 at the end. If you look at what this is, again, this represents 1, 2, 3. So you add those, 4, 5, 6, that's 7. And here, you have one of each, you add all of those. So 10, that is 15. So that's 157 in octal decimal. And let's do the same on the next problems. Oops, okay, oops, oh boy. I meant to do a race, and I meant to make this a straight line. Here we go, perfect. Let's go to the next number up. Again, they want it in octal. Since it's already written this way, I'm going to do both. So let's do octal and let's do 16. So if I want to go for 16, you don't have to do that in the homework. I'm just doing this to make sure that you really get it. So for 16, 2 to the 0, 2 to the 1st, 2 squared, and 2 cubed. And we're looking at these 3. Again, they have the first 3, 4, 5, 6, 7. If I made a mistake, you get the point. That's the same. That's the same. And if you add a 0 at the end to make them 4. So this is 7777 in hexadecimal. If I want to do what they want me to do, initially they wanted me to do this in octal. Well, I need to break them into 3s. 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0. And again, if you're missing a 3, if they're not 3, then you could add it then to make it a 3. And now here, we're going to only take 2 to the 0, 2 to the 1, and 2 squared, because I can't go above 8. So since this is 8, I check this, that's all of those, that's 7. This will be the first 2, 4 plus 2 is 6, 1 plus 4 is 5, 2 plus 1 is 3, and you add all of those, you get a 7. And that's what this number is. So that's the answer they wanted, because they said do this in octal, but I'm going to do the expansion on every single one every time. So here, do remember, it's a bit annoying to remember, but here it is. A, B, C, D, E, and F. That is 10, 11, 12, 13, 14, and 15. Again, you can't go above 16, otherwise it'll divide into 16. It says convert this from its hexadecimal expansion to binary. Okay, well, to binary, let's see how we're going to do this. This is going to be a bit of work. Well, not quite. So if I want to write, and remember how this works, if I want to write the letters, that is 11, 10, D is 13, F is 15, A is 10, C is 12, I'm going to expand that in a minute, E is 14, and D is 13. Hopefully I didn't mess it up. 1, 2, 3, 4, 5, 6, 7, 8, 6, 7. Okay, there it is. So if I want to write it in binary, then I'm really looking at, well, let's see. I have 2 to the 0, 2 to the 1, 2 squared, and 2 cubed. To get an 11 out of this, well, that must be 10, 11. So that's 1, 0, 1, 1. To get a 10, the way I can get a 10 is 8 plus 2. So that is 1, no 4, and no 1. So 1, 0, 1, 0. To get a 13, 10 plus 1, so that is 1, 0, 1, 1. That's the 13. 15, that is 15. That's all of them, if I'm not mistaken. Did I have a 15? B, A, D, F. F is 15. So we get 15. 8, 10, 14, 15. So that is 1, 1, 1, 1. To get a 10 is 8 plus 2, so those two. So 1, 0, 1, 0. A 12, 8 and 4 is 12. 1, 1, 0, 0. To get a 14, 8, 12, 14. The first three only. And the last would be a 13. 8, 12, 13. You skip the 2, so that's 1, 1, 0, 1. Now, if I want to take that and make it into an octal, I'm going to take, I can't have an 8, of course, and I need to split, oh, let me think. Yeah, no, I need to break this further. Actually, you can't go from this to the 8. I'm overdoing it now. That's not wise. Okay. Now there you go to exercise 6. This was exercise 6. And it says convert those to hexa. Now from the 2 you can go to the 8 and to the 16. And I'm going to do that on each one of those. So let's take the first number. If I look at the first, if I want to go to hexadecimal, and I'm going to do octal as well. So if I want to go to hexadecimal, I want to split those into 4s. They're already into 4s. And remember how that works. 2 to the 0, 2 to the first, 2 squared, and 2 cubed. Well, one of each. If you add all of those, what would that be? That would be 8, 12, 14. That's 15. That was the letter F, I believe. Yeah, there it is, F. So that is F. And I have those 4, 5, 6, 7. And if I want to go for 8, I need to make those into 3. So I need to make that 1, 1, 1, the first 3, then 0, 1, 1, and then 1, 1, 0. And I'm going to take only the first 3. So this is actually 4, 5, that's a 7. That will be the first 4 plus 2, that's a 6. And this will be the first 2, 2 plus 1, that's 367. And hopefully this is going to clarify it. Again, this is something that's a must in programming. You need to get that out of the way. We're going to do this both ways as well. So since it's already set for 16, let's go for that. And again, 2 to the first, 2 to the 0, 2 to the first, 2 squared, and 2 cubed. So 8, 0, 8 plus 2, that's a 10. 10 is letter A. And that's a letter A and letter A as well. That's triple A. Hey. And if you want to go for an 8, then what you're going to do, you're going to say that is 0. You know what, let me put it on the side. So that's going to be 0, 1, 0, those three. 1, 0, 1, 0, 1, 0, and 1, 0, 1. Hopefully I didn't, let me see, that's 3, 3, 3, and 3. Okay, that matches, perfect. And if I want to write that to an 8, again, I'm going to look at the first three, so those would be the first and that's a 5. This will be just the middle, that's a 2. This will be a 5, and that will be a 2. And there it is. Really simple. I hope you're seeing this as easy as I do. Let's do the next one up. C. It's already set for hexa. So 8, 4, 2, 1. Oh, no, it's of this. 4, 4, 4. You add a 0 at the end. There it is. So here you're going to add those 4, 5, 6. That's 7, 7. Oh, hey, that's easy. And if I make those into threes, that's 1, 1, 1, 110, 101, 0, 11, and 111. Remember, I added that 0. You could add as many zeros to the left as you like, it's not going to matter. And here I'm just going to take to an 8, I'm just going to read the first 3. So this is all of them, that's a 7. This is the last two, 2 plus 1 is 3. The first and the last 4 plus 1 is 5. The first 2, that's a 6. And all of them is a 7, and there it is. So hopefully by now you're getting sick of this, which is a good thing in math to get sick of an expansion, and hopefully the rest will be all practice. Here we are, here we are, here we are at a 0. So 8, 4, 2, 1. If I want to go for 16, this has the second, so that's a 6. No, that's a 5. Same thing. But this is a 5. Oh, what do you know? And if I break them into threes, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, and 1, 0, 1. 3 each. Well, if I want to go for an 8, then I'm going to use those 3. That's those 2. That's a 5. That's a 2. That's a 5. That's a 2. And that's a 5. Oh, that's odd. Here they are. Okay, the next one up would be number 12, and number 12, they would like me to take this and write it as hexadecimal. I'm going to do both. Well, hexadecimal is already set for that. Again, 2 to the 0, 2 to the first, 2 squared, and 2 cubed. Oops, 2 cubed is 8. So here I'm going to have the first 2, 3. The middle 2, 4 plus 2 is 6. Only the first, that's an 8, and you could add 4 zeros, that's just a 1. And there it is. And if you want to go for octal, you're going to take that and split it into threes. So 1, 1, 0, 0, 100, 0, 0, 1, 100, and 1, and you could add 2 zeros. And if you want to go for make it an octal, you only use the first 3. That is a 3, that is a 4, that is a 1, that's a 4, and that's a 1. There it is. Really simple. Nothing to it. No tricks whatsoever. And instead of doing another even, I decided to pick a part of your homework and do it just so that you have a good idea of how this works. Now adding, we're not going to do multiplication, not because it's hard, because it's really long. Really, nothing more. It's, you know, multiplying those turns out to be a lot of numbers. You could pick that up when the time comes. So I went ahead for number 21, and it says find the sum. And multiplication, we're just going to do the sum. If I want to add those in binary, remember, every time you get to a 2, you reset. So 1, 1, 1, 0, 1, 1, 1, 1. They match, so that's good. If I want to add those, remember, every time I get to 1 plus 1 is 2. That's a 2. That's a 3. That's also a 3. That's a 2. That's a 3. That's a 2. Oh, wait. 0, 2, 2. Yeah, that's right. And that's a 2. And that is 1 carry the 1 over. There it is. So that's what it is. And to really see it, if it matches the back of the book, write them in 4s always. That's how they write them in the book. There we go. Leave some space. That's what the sum is if you're going to add those. And if you want to go for 8, remember, every time you get to 8, you're going to reset. So if I take 1, 1, 1, 1, and 7, 7, 7, if I really want to add those, then 7 plus 1 is 8. 7 plus 1 is 8, 9, 1 over the 8, 7, 8, 9, 1 over the 8, and that's a 2. That's if you want to add them. Again, multiplying them will take a while, and that's pretty much it for this section. That's all there is to it.